Good morning, everyone. Welcome back to my channel. Today's our topic is algebraic expressions. Okay, this is grade 7 topic, children. Today we are going to learn algebraic expressions. Okay, now before going to learn this lesson, we need to know these keywords in this lesson. Okay, these are very important keywords, children. If you understand this keyword, then you can easily understand the whole topic. Okay, let us see what are those. First, what is constant? Constant is nothing but, children, a symbol which has a fixed value, no changes in that. Then that is called a constant. Okay, means it has a fixed value, no changes. Right? Understood, children? For example, like 2, 11 by 7, 5, and so on. Clear? See, 2, no changes. Okay, minus 11 by 7. There minus 11 by 7. Here also no changes in the value. 5. Like that. These are the examples. Next, what is variable? Variables are nothing but it doesn't have any fixed value. These variables are nothing but it like variables, children. Means in our English alphabets you have an idea, right? X, Y, Z, A, B, and so on, like this. Any letter you can take it. Okay. So these are nothing but what, children? Variables. It doesn't have any fixed value. Means X value we may change. Okay. And even Y value also, it is not only equal to every time Y equal to 1, Y equal to 2, like that. So okay, it will change. So that's what variables are. Doesn't have a fixed value. Doesn't have a doesn't have fixed value. Clear? Next, term. What is that? Next one is term. What is this term? Terms are nothing but it may be a constant or it may be a variable or it may be a product of both constant and variable. Got it? Means terms are nothing but a variable or a constant. Just I am writing short form, children. Or it may be both the product of constant and variable. Constant and variable. C into V I wrote, children. Means it's like nothing but product. Okay, fine. Now, for example, I'll show you. I'll give the example, children. Then you can understand. See. What is that example first? Variable I said, right? Let us take one variable. Means just before we discussed now, like this. This is also a term. Okay? Or a constant. 2. 2 not only 2, you can take any number. But that is also a constant. Okay? Next. And one more I said, it's a combination of, it's a product of both constant and a variable. Okay? Means one constant I am taking, okay, and a variable also I am taking. Product they said, right? Means into x, 2x. Isn't it or not? So this is also a term, this is also a term, and this is also a term. X is one term, 2 is one term, and 2x is one term. Got it, children? So these are the main 3 keywords, children. Okay? Understood, everyone? Constant is nothing but main important point. It has a fixed value. No changes in that. Variables are nothing but it doesn't have a fixed value. Means it will change. Clear? So, and term. Term is nothing but it may be a variable, it may be a constant, or it may be a product of both constant variable. Right? Clear, children? Now next let us see one more concept. Next, terms. Okay. In these terms we can see 2 types of terms, children. First term is numerical terms. What is that? Numerical terms. Numerical terms. What is this numerical term? Numerical terms are nothing but, for example, 2, 3, 4. These are all what, children? Numerical terms. Clear? These we can also call constant as well as numerals also, right? That's what I can say this one as a numerical term. Clear? Yeah. And next one is what? Algebraic terms. Means in these numerical terms, only numeral will be there. Okay. Yeah. Next. What is next? Algebraic terms. What is this algebraic terms? Means only variables. Only variables will be there in this. Okay. For example, 2, I mean, A, B, okay, and 2x and 3y and so on, like this. Okay, algebraic terms is nothing but it is a like this variables as well as both the combinations. Before we discussed, right, term is nothing but numerical terms are there and only variable terms are there, and both variables and constant terms are there, right? This both variables and constant terms product is comes under algebraic terms only. Okay, clear children? Here this only variables and both the combination also will comes under algebraic terms, but in the numerical terms we can see only the numerical values. Clear? Here we don't have any algebraic letters, but in this algebraic letters we can see the numerals as well as means combination, not only single variable, a single numeral. We are taking the combination of variables and numerals. Clear? Yeah, these are the algebraic terms and these are the numerical terms. Clear children? Next we'll see two more types of terms children. Those are like and unlike. Okay? Yeah. Yeah. Next, what is that? Next, two more types of terms. Like terms. Like terms. In generally, what is the meaning of like? Like is nothing but similar, right? Here in the terms which is similar means see the numbers. I mean the terms which is having a variable and exponent should be similar. Then those are called like terms. Okay, let us see some examples. Suppose 3xy and also next 4xy. Once you observe these two terms children, this is one term, this is one term, right? Now if you observe these terms, x, y variable I am using, and in this term also I am using x and y variable. Means are they similar? Yes. And we need to check exponent also. Are they similar or not? I mean, here exponent of x is 1, here exponent of y is 1, here 1, here 1. Is it same? Yes. Right? So here that's what we can say that these terms are like terms. Clear? Yeah. Next, one more example. 2x square and 3x square. See, here also I am using x, here also I am using x, and at the same time the exponent is also same. That's what these two are like terms. Clear? So like terms are nothing but the terms which are having the similar variables as well as exponent also will be similar. Then those are called like terms. Okay. Yeah. Next, let us see the second one. Unlike terms. What is unlike terms? Unlike terms are nothing but the terms which are having different variables and different exponent. Okay. For example, 3x square y and 2xy square. See, I'm using the variables are similar, but exponent are different. Did you notice that? So that is what these are unlike terms. Clear? Like unlike means see, not only variables. You should also check the exponents. Okay, variables are similar, but the exponents are different. That's what these are unlike. Clear? Now, even in like also children, one more important point. Don't check here numerals are they similar or not. Just we need to check the variables and its exponent should be similar. Okay. Don't think about these numerals are they similar or not. This is one more important point. Clear? Yeah. So understood now like and unlike children? Clear? Yeah. Next we'll see the one more concept. Yeah. Now next concept is coefficients. What is this coefficient? Coefficient is nothing but, see, I will take one example and explain with one example. You can understand easily. See, now I am taking one example. Suppose 5x square. 5x square is nothing but what, children? 5 into x square, right? Yes. Means, can I call 5 is a factor of x square? Right? And x is also x square is also a factor of 5. Yes or no? So means what are the factors of 5x square? 5 is a factor of 5x square and x is also a factor of 5x square, right? Yeah, in this factors, if you observe that whatever it has a numerals are there, no? These numerals are called numerical coefficient of this term. Okay, whatever we can see the factors, okay, that two numeral factors are called nothing but numerical coefficient of this 5x square, and whatever we see the variable factors is nothing but variable coefficient or literal coefficient. Clear, children? Yeah. Let once again I'll explain, children. Here 5x square one term. Okay. This is an algebraic term. In this now 5x square, 5 is a factor of 5x square and x is also a factor of 5x square, right? Yeah. Whatever we have, this numeral value is there. That numeral is nothing but we can say that numerical coefficient of this x square. Okay, and next whatever we have, x is a factor, right? That x we can also call it as a literal coefficient of 5. I mean this whole. Clear, children? Yeah, so this is nothing but coefficient, children. Okay, in coefficients also we can see numerical coefficient and literal coefficient. What is the numerical coefficient is nothing but a numerical number which is a factor of the given term, and literal coefficient is nothing but a variable which is having a factor of a given term, right? Yes, so means in this term 5 is a coefficient of x square and x square is also a coefficient of 5. X square is a not only coefficient, we can also say that literal coefficient. Literal is nothing but variable only, children. Clear? Yeah, this is about the coefficient. Clear, everyone? Yes. Next, let us see one more concept, children. Okay? Yeah. Yeah. Next concept is expression, children. What is this expressions? In expressions are like algebraic expressions, children. Okay? Expressions are nothing but a single term, it may be, or a combination of terms. Those are connected by symbols. Symbols means four operations, either multiplication or division or plus or subtraction. Okay? Yeah. Means what is the expression, children? It may be a single term or a combination of terms connected by the four operations. Clear, everyone? Let us see the example. First, I am taking one 3x. Is this a term? Yes. In this term, variable is there and numeral is there, right? Yeah, means this is also one expression. Clear? Yeah, next. 2y plus 1. Is it an expression, children? See? Yes. Here, this is one term and this is also one term. And these two terms are connected by a symbol, that is plus, right? Yeah, here also these two are connected by a into operation, right? I mean multiplication operation we can also represent it by a dot. Okay. Yeah, next if you see another one, 3y plus 2. See, here also we have two terms. These two are, suppose here I am taking minus or division, anything you can take. Like this, whenever one term or combination of the terms, okay, are connected by the four operations are called expressions, children. Okay. Yeah. In this also again we can see the two types. Okay. Yeah. See. And is this a term expression, children? Yes. 10 is also an expression. Okay. Yeah. See. Now here if you see this, we can see here it's a combination of variable and numeral is there. Okay, and here also it is a combination of numerals and constant, isn't it? Yeah. So in this, I told you two types, I said, right? Yeah. Whatever we have the algebra, variables and numerals combination are there, no? Those are called algebraic expressions. What we have to say? Algebraic expressions. You can say that algebraic expressions. What are algebraic expressions, children? 3x. In this example, which are algebraic expressions? See, 3x. Before we discussed, at the time of terms, numerical terms and algebraic terms, same like this only. Now we are calling here expression because it is connected by the symbols, right? Yeah. Now 2y plus 1. It is also an algebraic expression, right? Yeah. Now next, second one is numerical expression. Numerical expressions means only numerals. Or we can see only the numerals, right? Means 3 plus 5. This also one numerical expression. Okay, means here in this example 10 plus 2, 10 minus 2, like that we can take. Okay, not only 10, because we said the expression is nothing but connected by some symbols, right? Here only 10 is there before. I didn't take the operation. Now see, this is a actually correct one. 10 plus 2, right? That is a one expression. Which type of expression? Only numerals are there. That's what that is called numerical expression. Clear? Yeah, only numerals will be there in the numerical expression, and in algebraic expression we can see numerals as well as constant and the combination of both also, right? Those are called algebraic expression. Clear, children? Before, what did we learn? Terms we learned, and before after that we learn coefficient we learn, and after that expressions. In terms we saw the two types: algebraic terms, numeral terms, and next we learned about the like terms and unlike terms, and now expressions. In expressions also algebraic expression and numerical expression. Clear till here? Now next we'll see the another concept, children. Yeah, next we'll see the next concept is types of algebraic expression. What are those types of algebraic expressions? Let us see. First one is monomial. What is that? Monomial. What is a monomial? Monomial is nothing but, children, single. Okay, only one term. That is called monomial term. Okay, in that monomial term, it may be a numeral term or single, or it may be a algebraic term. See, means minus 7 is a numerical term. Single, right? That's what it is, a monomial. Or you can also take x. Okay, that is a monomial term. Or you can also take 3xy. This is also a single term, right? So means a variable, a numerical or a variable or a both the combination, numerical and variable. Okay, whatever it may be, but it should be a single term. That is nothing but monomial. Clear? Yeah, next we'll see the binomial. What is binomial? Bi. In general, what is the meaning of bi? Means two. Means in algebraic expression, if it is two are there, two terms, then I can say that it's a binomial. Means like this, 2y plus 1. It's nothing but it is a, this is one term, this is another term. Then that is called binomial expression. Clear, children? Or we can take one more example, x square minus 7. That is also, this is one term and that is one term, another term. So binomial. Next, trinomial. What is trinomial? Trinomial is nothing but tri. What is the meaning of tri? 3. Means in a expression, if we have 3 terms, then I can say trinomial. Means 3x square plus 2y plus 1. One term, this is the second term, this is the third term. Right? Yeah, so this is nothing but trinomial. Okay, an expression has more than the 3 terms, then we can say that that is a polynomial. Okay, We can say that what, children? Polynomial. Polynomial means what? More than 3 terms. Okay. 3. Then we can say that that is a polynomial. Okay, children? Yeah. So these are the 3 types of algebraic expression. What is first? Monomial. Monomial is nothing but mono means single term, and next binomial means 2 terms. An expression should have 2 terms, and trinomial means in an algebraic expression should have the 3 terms, and polynomial is nothing but more than 3 terms is nothing but a polynomial. Clear? Yeah. So next we'll see the another concept, children, that is nothing but degree of an expressions. Okay, how to say what is the degree of these all the expressions. Okay, yeah. Now first we'll see the monomial terms ki how to find out the degree. Okay, before going to find out the degree, first of all, what is the degree? I'll tell you. Okay, yeah. Next concept is degree of algebraic expressions. Okay, first we are going to find out the degree of a monomial term. First of all, what is the degree? Degree is nothing but, see, with this example I'll explain clearly. Now here 3xy is there. Means it's an algebraic expression, right? That too single term is there. This is completely one term, children. Don't think like this is different, this is different, this is different. These are all under multiplication, means it's completely like 3xy is a single term. That's what it's a monomial expression. Now how to find out the degree of this term? Means first look at the exponent. What is the exponent of x? 1. What is the exponent of y? 1. So like this, in a single term, 2 variables are there, means you should add those 2 exponents. Okay, that too they are under multiplication, right? So, and that too they are in a single term, same term, right? Not separate terms. In a same term, 2 variables are there, means we need to add those powers. Then how much it is? How much it is? 2. So, it 2 is nothing but degree of this term. Clear, children? Yeah. So, this is the way we need to find out the degree. How did I find out the degree of a term, children? This is the only term I am saying. Okay. You need to add the exponent of the variables. Single variable is there, means not a problem. We can say easily. Okay. But here 2 variables are there in a single term, means we need to add the powers. Got it? Yeah. This is the way we need to find out the degree of a term, I'm saying. I'm not saying the degree of whole. This in the monomial, this is a only one term is there. That's what I can say. This is a 2. There is no another term. Let us see another term. If it is 2 terms are there in an expression. See, means it's a, if 2 terms are there in an expression, means what we have to say? It is a binomial expression, right? In this binomial expression, now how to find out? Before it was single, right? That I can easily find out. But here 2, this is one term, this is a one term. How to find out then? Means see, first you need to take the degree of individually first, each and term. This first term, what is the degree? Only single variable is there. Whatever exponent is there, that is only the degree of that term. So 2 is the degree of this term. Right? Yeah. Now in this term y power 1, nothing is there, means exponent is 1. So what is the degree of only this term? 1. Then here in this expression 2 terms are there. Then which one I have to take? We have to take this one as a degree or this one as a degree, means whichever has the highest value, that is only the degree of that whole expression, children. Okay, got it, children? If in a algebraic expression 2 terms are there, means how to decide the degree? Which term degree is the final, means which term is having the highest power, that is called degree of that whole expression. Got it? So now what is the degree of this expression now? 2. Clear, everyone? Yes. Before here, it's a monomial. Single is there. That's what we can say easily. But if it is 2 terms are there in an expression, means we have to say like this. Next example. This is what, children? This is a binomial term. Means in case if it is a binomial expressions, how to find out. Next we'll see the trinomial also. in a trinomial, how to find out? Now let us take 4x square 2xy z 2xy plus 2. Yeah. See children now. Is this a trinomial? Yes. In this, three terms are there. Then how to find out the degree? Means first we need to take the each term degree, we need to write it here. And then we need to decide which term is having the highest degree. That is only the degree of whole expression. Clear? Yeah. So now here, if you see that in the first one, 4x cube. 4x cube means 3. Only single variable is there, right? That's what I can say easily. The degree of this term is 3. Yeah, in this term, children, we have two variables. If it is two variables, how to take degree? Already we discussed in the monomial. In a single term, two variables are there means we need to add those exponent I said. Means 1 plus 1 how much? 2. Means this term degree is what children? 2. 1 plus 1 how much? 2, right? Understood children? How did I write the degree of this term? Yes. Now here 2. 2 is a constant. It's nothing but 2 power 0. Right? Nothing is there means 1. So it is 1. Okay. Yeah. Now here in this children, what is the degree? 3 is the degree. Why? Because in this all this term which is having greatest value 3. 3 is the greatest exponent. That's what we can say that the whole expression degree is 3. What is the answer? 3. Clear everyone? So this is the concept of degree of an algebraic expression children. Okay? Yeah. Till now everyone understood, right? Yeah. Next let us see the another concept. Now, next let us see the standard form of an algebraic expression. What is the standard form of an algebraic expression? Means is nothing but if the terms are arranged in a descending order, then we can say that it is in a standard form. Usually we know that for fractions, what is the standard form, for decimals, everything, right? In that way, here also we have a standard form children for algebraic expression. When we can say an algebraic expression is in a standard form means whenever we'll arrange those terms in a descending order, then we can say that it's a standard form. For example, yeah, see here, if you observe these three terms, here what is the exponent of 1? Exponent of x 1, here exponent of x 2, here 1 constant. So once you notice that, are the exponents are in arranged in a descending order? No. See, 1 is smaller than 2, right? Means it is not in a descending order. So means it is not in a standard form. Okay, standard form is nothing but whatever is having the highest exponent, that term should come first. That is the reason I told you descending order. Descending order is nothing but decreasing, like big to small. And next, which is the next smallest exponent? This term we had to write. And next, finally, constant. Got it, children? What is the standard form of an algebraic expression? We need to arrange in a descending order. Okay? Yeah. That's all, children. These are the basics of algebraic expressions. Clear? I hope you all understand, children. Thank you. Have a nice day.